Hello everyone, myself Siddharth Koikar and I from 3rd year ANTC department. As a part of ISE for subject of digital signal processing, we are presenting with under guidance of our course in charge Professor Mr. R.T. Patil sir. Our group is going to present. The topic is frequency response of second order discrete time signal. My group consists of Sneha, Bhakti, Teja and me. Now let's begin the presentation with the concept of frequency response of second order discrete time signal. Now, firstly, let us understand what is frequency response. Frequency response of a system is complex function which is plotted with respect to various values of omega. Here, a graph whose x-axis is omega in terms of radian and the y-axis is complex quantity, that is h of e raised to j omega. So, frequency response, because it is complex, we cannot directly plot a complex number. So, I will transfer into a polar representation which will have its magnitude and phase. Here, magnitude when plotted with respect to omega is called as magnitude response, and phase when plotted with respect to omega it is called as a phase response. So we can say that frequency response have actually two responses, or its combination of two responses. One is called magnitude response and second is called phase response. We will have two responses which combine together, it gives as a frequency response. Then next we will see an example of frequency response and simulation. Further part will explain my group member.
Now, let's understand the concept of frequency response of second order DFT with the help of one example. Let's take an example. Y of n is equal to 1 by 6 x of n plus 1 by 3 x of n minus 1 plus 1 by 6 x of n minus 2. Here we have to calculate magnitude and the phase response of the given system. And then first of all we have to take the z transform of the given system. Then it will be y of z is equal to 1 by 6 x of z plus 1 by 3 z inverse of x of z plus 1 by 6 z raised to minus 2 of x of z. Then by rearranging the equation, we will get y of z upon 6 x of z is equal to 1 by 6 plus 1 by 3 z inverse plus 1 by 6 z raised to minus 2. Here we already know that h of z is equal to y of z upon x of z, which is impulse response of the given system. Then the equation will be h of z is equal to 1 by 6 plus 1 by 3 z inverse plus 1 by 6 z raised to minus 2. Here by replacing z with e raised to j omega, we will get the equation h of z is equal to 1 by 6 plus 1 by 3 e raised to minus j omega plus 1 by 6 e raised to minus 2 j omega. By rearranging the given equation, we will get e raised to minus j omega in bracket 1 by 3 into 1 plus cos omega. Here we know that standard equation h of e raised to j omega is equal to magnitude of h of e raised to j omega into phase response of h of e raised to j omega. Then by comparing with this equation, we will get the magnitude of h of e raised to j omega is equal to 1 by 3 1 plus cos omega, and the phase response will be minus omega.
I am here to explain the ISE2 of digital signal processing. Our topic name is frequency response of second order discrete time system. I am here to present the MATLAB code for frequency response of second order discrete time system. This is the MATLAB code for second order discrete time system. First, I will explain the MATLAB code, then explain the output. Clear all, this command is used for clear all the previous work. J is equal to square root of minus 1. This explains the value of j is equal to square root of minus 1. Omega, here we define omega, magnitude of h, phase of h. R is equal to 0.n. Omega 0 is equal to pi by 2. With this command, we define the omega 0 angle. A is equal to minus 1 into R into cos omega 0. Alpha is equal to 2 into A. Beta is equal to R square. For value of omega 1, minus pi to pi with the steps of 0.01. Uh, for the frequency response of discrete time system, we have to define a transfer function. So for transfer function, we have transfer function is a ratio. Numerator of transfer function is given by 1 plus a into e raised to minus j omega 1. Denominator of transfer function is given by 1 plus alpha into e raised to minus j omega 1 plus beta into e raised to minus 2j omega 1. Transfer function is a ratio. As we define, transfer function is the ratio of output upon input. Uh, that way, transfer function is given by numerator of h upon denominator of h. Numerator of h and denominator of h is defined earlier here. Uh, for the magnitude of transfer function, we have to consider absolute value of h. So this command is used for magnitude of transfer function. For the phase of transfer function, we have to consider angle of transfer function. This h underscore p is equal to angle of h. This command is used for phase of transfer function. Magnitude of h is given by magnitude of h underscore m. H underscore m is defined here. Uh, Similarly, phase angle of h, transfer function is defined here. Omega is equal to omega to omega 1. Omega is equal to omega 1. This is the limit of phase angle. And subplot command is used for the plot of graph. Subplot first म्हणजे 2 defines the number of rows. Second digit defines the number of columns, and third defines the number of graphs. Plot commands is used for uh, plot the 2D graph. Plot omega magnitude of h. For this, x label is omega in radians. Y label is magnitude of transfer function h j omega. Subplot 2 is the command used for plotting second graph of phase of transfer function. Plot omega phase of h. X label is omega in radians. Y label is phase of h j omega. This is a code for frequency response of second order discrete time system. Output of frequency response of second order system is like this way. First graph describes the magnitude of transfer function, and second graph describes the phase of transfer function. As we define the x label is omega in radians and y label is magnitude in magnitude of h j omega. Similarly, here phase of transfer function. Thank you.
Advantages of frequency response. First, using frequency response distribution, they present raw data in an organized, easy to read format. Second, the most frequently occurring scores are easily identified. Then, disadvantages of frequency response. First, frequency response requires transfer function of plan be known. Second, it is difficult to infer all performance value. Third, frequency response are hard to extract steady state response format. Thank you.